Please pause this video and try the warm-up. You're using the graph of this rational expression to complete these statements down here. All right, hopefully you should have gotten that as x approaches 3 from the left, f of x is heading towards positive infinity. As x is approaching negative 3 from the right, f of x is approaching negative infinity. And as x is approaching infinity, f of x is approaching negative 1. All right, let's go ahead and continue with section 3.5, rational functions and their graphs. So we're going to continue graphing rational functions. So here's our first example. We are going to graph f of x equals 2x divided by x squared minus 4. Remember, we always want to make sure that our function is as simplified as possible, because then if it isn't, we have to simplify it before we can graph. Notice that the numerator is not factorable, however, the denominator is. X squared minus 4 is the same thing as x plus 2 times x minus 2. So once I have everything as factored as possible, I can see that, hey, there's nothing in the numerator that's also in the denominator. I can't simplify this down any further, so I'm going to be able to use that to then graph. So remember, we've got our different steps. So first thing we want to do is we want to check for symmetry. That means we have to substitute in negative x into our function. So I want 2 times negative x divided by, I'm gonna go back to my original denominator here just to make my life a little bit easier when I'm doing that. So we'll have negative x quantity squared minus 4. So notice that the numerator will turn negative. The denominator is going to actually stay the same. So while not every term was the identical thing once we substituted negative x, or since every single term did not change sign, there is no symmetry here, which really then is going to affect at the very end when we have to plot points. We're going to maybe have to do a couple more points than we would if we had symmetry. Okay, remember the second thing we want to look for is a y-intercept. So that means I'm substituting 0 into my function. Well, if I substitute 0 into the numerator and 0 into my denominator, once again, I'm going back to my original denominator for that, I see that I'll have 0 divided by negative 4, which means it's 0. So 0, 0 is a y-intercept, and I can go ahead and I can plot that point. I need to find then, for my third step, the x-intercept. So my x-intercept is setting the numerator equal to 0 and solving for x. So notice that when I divide both sides by 2, x equals 0, which then tells me, and it makes sense, that if my y-intercept is at 0, 0, my x-intercept is at 0, 0 as well. I need to draw in vertical asymptotes. So remember, vertical asymptotes take place by looking at your denominator and never having your denominator turn into 0. Well, I'm going to now look at my factored denominator. I need to set each of those factors with an x equal to 0. So that means that because I've got 2 different factors, I've got 2 different equations, so I'll have 2 different vertical asymptotes. I'll have to subtract 2 for one of the equations, and I'll have to add 2 for the other. So those are my 2 x-intercepts, vertical asymptotes. And remember, they have to be as a line. So x equals negative 2 means that I have this vertical line right here that I want drawn into my graph. And x equals positive 2 means that we have a vertical line here at positive 2, which also needs to be drawn. Okay, fifth step is looking for horizontal asymptotes. So remember, that means we look at the degree of the numerator and the denominator. Well, the numerator has degree 1, the denominator has degree 2. So that means because the top is smaller than the bottom, I'm going to have a y-intercept, a horizontal asymptote at y equals 0. So technically, we've got a horizontal asymptote here. Now, notice that my x and y intercept is actually on the horizontal asymptote. So there is this situation where your graph could potentially go through the horizontal asymptote. Usually that occurs when you have a When you have two vertical asymptotes, usually it happens more in the middle or in between those two rather than the outside. Okay, so just know that vertical asymptotes, absolutely 100%, you cannot go through them. Horizontal asymptotes, it's kind of like a hit or miss. Sometimes you do, sometimes you don't. Okay, anytime it's in between them, you are sometimes going to at least touch it, if not cross it. Okay, so now that I've got every piece of information from those 5 steps, I obviously don't have enough to figure out what my graph looks like, so I am going to have to plot some points. So you can write it as f of and put a number in. This time I think I'm just gonna like make a little table here. Remember, I wanna create values or pick numbers that are gonna be on either side of the vertical asymptotes and then in between the x-intercept. So notice that one of my vertical asymptotes at -2. So I'm going to pick -3 and -4. And then because it's not a mirror image, I am going to have to then pick a lot more values for then the other side. Notice that with my x-intercept being at 0, I can then pick -1 and +1 to pick numbers that are surrounding that. And then because I don't have a mirror image, I am going to have to pick a couple of points to the right of that x equals 2 line, so 3 and 4. So we have quite a few numbers that we have to plug in to see what kind of function we're going to have here. Okay, so when I plug -3 in, so 2 times -3, and then we can have -3 squared minus 4. So that's going to give us roughly -1.2. So at -3, we've got -1.2, so a little bit below -1. When I plug -4 in, I'm going to run out of room, so I'm not going to do that. So I'm going to put it into my calculator. Looks like I get -0.6 repeating. So it looks like it's getting closer to that horizontal asymptote. Okay, so it's going to get closer and closer and closer to each of those vertical and horizontal asymptotes. Let's see what's happening in between the x-intercept. So at -1, looks like we're going to get a positive 0.6 repeating. So that means that I want a number that is up close to +1 there. If I plug +1 in, it looks like I get -0.6 repeating. So I'm back below. So notice that it is going to turn into somewhat of a cubic looking function in between. Now on the right side of that x equals 2, if I plugged in 3, let's see, we would have 2 times 3 over 3 squared minus 4. So it looks like we'd have 6 over 5. So that's going to approximately be +1.2. And so at 3, we want 1.2. Okay, if I plug 4 in, looks like we're going to get 0.6 repeating. So once again, it's kind of getting close to the horizontal asymptote there. So notice that this time that part of the graph is above the horizontal asymptote. And so that is my graph. So it took quite a few numbers getting plugged in with like this table, but sometimes it might be less depending on if you have symmetry or not. All right, let's take a look at this next example. We've got to graph f of x equals 4x squared over x squared minus 9. So once again, if I look to see if everything's as simplified as possible, I can't factor a monomial. I can factor this denominator into x plus 3 times x minus 3, but there's nothing in the numerator that's also in the denominator, so I can't simplify any further. Okay, so let's start by looking for symmetry. I'm going to plug -x in. We've got then 4 times -x quantity squared over, I'm going to go back to my original denominator, -x quantity squared minus 9. Well, when you square a negative, it's going to turn positive. So we'll have 4x squared on the top and then x squared minus 9 on the bottom. So notice that I get the exact same thing from plugging negative x in as if I just plug positive x in. So that means I do have symmetry. It means I have y-axis symmetry. So that's the nice thing about that, is that we will definitely have less points to have to plot when we're making like a table, because we know that we do have symmetry, a mirror image on that y-axis. All right, now I want to find my y-intercept. So I'm going to substitute 0 in to all of the x's, and it looks like we would have 0 in the numerator and -9 in the denominator, so that'll turn to 0. So 0, 0 is going to be my y-intercept, so I can plot that. I know that I have to find the x-intercept by setting the numerator equal to 0. So if I divide by 4, we get x squared to equal 0. Notice that when I take then the square root, we'll still get 0, but technically we do have a multiplicity of 2. So while we do have 0, 0, think about this. This is a multiplicity of 2. So when we were talking about graphing polynomials, that meant that is going to touch and turn. So that's the same thing. So somewhere in this rational expression here, it's going to be touching and turning. We've got our fourth step is figuring out the vertical asymptotes. So that means I want to set my denominators equal to 0. So that's where I will use the factored denominator. I've got two equations here. I'll have to subtract 3 from the first one. So x equals -3. I'm going to graph that line. So make sure that I always have my vertical asymptotes on my graph. And then the other one, I'd have to add 3. So x equals +3 is my second vertical asymptote that has to be graphed. Okay, I need a horizontal asymptote. That means we're looking at the degrees. So in the numerator, I see x squared. In the denominator, I see x squared. So that means that I have to divide the lead coefficients. 4 divided by 1 gives me that y equals 4 is going to be my horizontal asymptote. All right, so we got through those 5 steps, and then now we definitely need to figure out what's happening on either side of the vertical asymptotes, as well as between the x-intercept here. So I'm going to make a table, but remember, this table we can actually have a lot less numbers because we do have y-axis symmetry. So we either can focus on positive numbers or negative numbers, but then it'll just be a mirror image on the other side. So I think I'll stick with positive numbers. So let's say if I need something in between the x-intercept, I can either pick 1 or I could pick 2. It doesn't really matter. I think I'm going to pick 2. So if I substitute 2 in, it looks like when I plug all of that into my calculator, I'm going to get around -3.2. Okay, so that means that at 2, I'll have -3.2, but that means that at -2, I'll also have -3.2. And remember, multiplicity here, that means that because it was a even multiplicity, we got touch and turn there. So notice how it kind of looks like a parabola in the middle. All right, so now I need to pick something that's happening on the right-hand side of that vertical asymptote of x equals 3. So I'll pick a couple of points. Let's do definitely 4, and let's do 5. All right, so if I substitute 4 in, looks like we'll get around 9.14. So at 4, I want to go up 9 and a little bit past 9. So that means same thing at -4. I get to go up to that 9.14. If I substitute in 5, looks like we're going to get about 6.25. So at 5, we've got 6.25. So same thing over here at -5, we'll have 6.25. Okay, and so then we're going to be curving and heading towards, that didn't stay. Oops, I want that at 5. curving towards those vertical and horizontal asymptotes. But notice that it should be a mirror image. So if I was to fold one side over the y-axis, the other side would lie nicely on top of it. And there's my graph. Okay, so I would suggest that you pause the video and try this checkpoint problem. Okay, we should have gotten no symmetry. Our x and y intercepts are at 0, 0. We have one vertical asymptote at x equals -1. Because the degrees of the numerator and denominator are the same, our horizontal asymptote is dividing those Lie coefficients. So y equals -1 would be that horizontal asymptote. And then I picked some numbers surrounding. Notice that because 0 is my x-intercept and -1 is my vertical asymptote, I had to choose negative. Well, I chose something to the left, to the right. I chose these values down here. Obviously, you could have picked like -1/2 and different things like that to substitute in, but that should have been your graph. Okay, so that's us graphing rational functions.